This video is designed to go with section 14.3 from the Math for Elementary Teachers book by Musser. So in this video, we're going to talk about constructing a perpendicular line through a point given on the line and constructing a perpendicular line through a point that is not on the line. So we have two illustrations here. The first illustration is a line where we have a point P. And the second illustration is where we have a line and we can see we have a point P that is not on the line. So, what are the steps that we need to take for this? So, in order to construct a perpendicular line through a point that is on the line, we're basically going to follow the same exact rules that we did when we talked about doing a perpendicular bisector. So what we're going to do first, since we actually don't have a set distance here, okay, we don't know that it's going to be a bisector because there is no set length to this line. A line goes on for infinity. So what we're going to have to do is create the line segment first. So first we're going to place the point of our compass on point P, set a certain distance, and make an arc on this side intersecting with L. Do not change that distance and make an arc on the other side intersecting with L. Now I know that these two distances are exactly the same. I'm going to call this point S. And I'm going to call this point R. So now I pretty much do have a segment, SR, and I know that P is in the center because this is the same distance as this, okay, based on my construction. So now we have to create the perpendicular line, or in other words, it's the bisector. So we're going back to the other video where we created a perpendicular bisector. So how did we do that? First, we have to set our compass on point R and make an arc. Don't change that distance. Set our compass at point S and make an arc. And we are going to call this point Q. And now as we connect QP, we have made a perpendicular bisector. All right, how do we know that it's perpendicular? Well, we followed the same properties that we did for a bisector. So since we knew that we had SR as a line segment, by following the same exact properties and knowing that this is a 180 degree angle, what we just did is create the angle bisector, which we know would have to then make these two 90 degrees. So we just created the angle bisector. All right, moving on to constructing a perpendicular line through a point that is not on the line. First thing we're going to do is place the point of our compass at point P and construct an arc that intersects line L in two places. So we're going to put our compass point on point P and draw an arc that will intersect line L in two places. So here's one. Don't change the length of the arc. And find the other. Okie dokie. We're going to call this intersection point A. We're going to call this intersection point B. And again, let's take a step back and think about what we just did. We know the distance from P to A is going to be equal to the distance from P to B because that's how we set the radius of our compass. So that's how we're making those arcs. With the same compass opening, so again, we're not changing the compass. With the same compass opening, place the point of your compass at A to construct intersecting arcs on the other side of L. So not the side with point P, on the other side of L. So without changing this distance, I'm going to put my point at point A and make an arc. And I'm going to put my point at point B and make an arc. And we are going to call this intersection of the two arcs Q. Now, if we use a straight edge to connect P and Q, we have just created a perpendicular line through a point that was not on the line. But again, we have to justify how we know that it is perpendicular. So the justification is actually exactly the same as what we did in construction 3, that we have a rhombus. So because we're making a rhombus, PQ will be the perpendicular bisector. Let's think about why we have a rhombus. We said that it was equidistant for PA and PB. We did not change that distance when we put it at point A to make the arc and when we put it at point B to make the arc. And so that means that all 4 of these distances are the same length or they're congruent. And so again, what do we know about a rhombus? We know that the diagonals are perpendicular bisectors. And so because of the definition of perpendicular, we know that these cross at 90 degrees. So we've created a perpendicular line.